Hey there, this video is about STL vectors in C++ programming, and this covers section 7.12 in the Gaddis C++ book, right at the end of chapter 7. And to be clear, STL stands for the Standard Template Library, which is an add-on to the C++ language, so we should know about this. Okay, so the Standard Template Library, the STL, to be clear, it's going to come with your compiler installation. It's really not, it's a bunch of stuff that's really not part of the C++ language. When I was learning C++ quite a while ago, the Standard Template Library did not exist. So all this stuff here is, to me, new since I first learned C++ programming. Not part of the language, but it's a bunch of programming that some other people did in C++, and basically they provide it for free now. So on most installations of C++ compilers, you have these tools and these libraries and these add-on stuff in the STL, and they're very powerful and very useful. We're just going to be looking at one single thing here, the type called the vector. If you want to know more about the standard template library, that's deeper in the book in chapter 16, kind of talks more about that, but I would leave that for second semester programming. It's good to kind of get a taste here at the end of our first semester programming course of what the vector is about. Okay, so the vector data type is a lot like an array. It holds a sequence of values like an array does. Okay, so one thing after another, all the same type, just like an array. They're stored in memory in contiguous memory locations, one right after another. There's no gaps. It's easy to predict where it's going to be in memory, just like an array. And once you've stored some stuff in a vector, you can access those elements with the subscript operator. You want number 0, you want number 5, you want number 20, just like an array. In a lot of ways, it's exactly like an array. And the secret is how it gets its work done is it's storing an array. So it's not too surprising that it works like an array, because the truth is it's actually got an array inside it, as a matter of fact. Okay, so here are some advantages of vectors having wrapped arrays with some extra features. There's quite a few. Number one, you don't have to declare a fixed size when creating a vector. So whenever we make an arrays, basic arrays, you have to specify a particular integer constant for how big it is, and then you're stuck with that, and the programmer has to make the decision when they're writing the program before anybody uses it. Well, vectors, you don't have to do that. You do not have to specify a size in advance because, bullet point 2 here, your vector can actually grow in size as elements are added. So you add some stuff, it'll get bigger. You add some stuff, the vector will just grow to use up as much memory as you need for all that stuff. And obviously arrays cannot do that because you have a fixed size, and if you go past the end, you've got a buffer overflow and you're overwriting memory and the program crashes or something even worse than that. A vector automatically tracks its own size. So when working with arrays, you've got the array, but you also separately have to keep in mind what the size is. And we usually have a constant for that, right? And when you're passing an array into a function, we've been saying you need two parameters. You need the array, which is where it starts, and the size, so the function knows where it ends. Well, with vectors, the fourth thing here, now there's just one object to pass to functions because the vector is actually a package storing both an array and a size together, and now it counts as just one thing. So now if you're passing a big amount of data into a function, you just pass the one vector, not the two separate things. A vector can protect against buffer overflows. So whereas a basic array doesn't itself know where the end of it is, and therefore it's dangerous because you can overwrite the end of it, a vector does know its own size, and it can do some extra security to make sure that you do not write past the end of it and protect you from those terrible, terrible buffer overflow problems. And I would call this an advantage. It uses object-oriented syntax. Hopefully you remember what that looked like. We first saw that in this class when we were talking file handling. That's actually the last video right before this one. So you're going to be making an object, and the object contains an array and its size and a bunch of functions to do interesting stuff on that data. So to use those functions, you're going to be naming your vector dot name of the function. So object.function, and that is what object-oriented syntax looks like. So lots of advantages. Now, you might ask yourself, well, why would you ever not use vectors if they're so wonderful like this? And the answer is, professional C++ programmers probably do use vectors all the time as the very first thing they think of to store data. It's not wrong, frankly. But you want to know about basic arrays first because vectors contain arrays. They're actually built on top of arrays. So to understand how vectors work, you really have to understand arrays first. Secondly, other languages might not have vectors, but they always have arrays. So hypothetically, if you want to go back and you want to work in the C language, you're working on some kind of hardware perhaps that uses C programming. Well, the C language doesn't have vectors at all, but it does have arrays. Or if you're doing assembly language programming, there won't be any vectors, but you can use arrays. That's a very basic thing that processors are set up to handle automatically. So in other contexts, you might not have vectors as an option, but we do have it in C++, and it's very nice. And hypothetically, if you're using vectors all the time in the future, that's actually a wonderful thing. In the Java language, this same idea is called an array list, if you've ever seen that. But if you want to do this kind of thing in Java, it's an array list is what you've got. Okay, so if you're convinced that vectors are going to be wonderful for you, here is what it looks like when you use them. So first of all, you've got to include the vector library, because again, this is not built into C++ automatically. It's an add-on library, so you're going to have to pound include the vector library to use this. To create a vector, it's going to look different than when you're creating an array. Several different options here. So the most basic thing, you want to declare a vector, for example, to store integers. Right, with an array, you'd write int, name of the array, brackets. But here, for vectors, you say vector angle brackets int. That's the type of thing you're storing, and then give the name. So I would read this as I'm making a vector of ints. It's a vector to store a whole bunch of ints, and the name of this vector is scores. Maybe, maybe for test scores or something like that. I would recommend, as you follow this particular video, maybe take a piece of paper and jot down the syntax of the different things we're talking about. This is all new, of course. So maybe just jot down how you declare a vector here. That's probably the simplest option, but there's more. Here's how you can declare a vector and establish the initial size. So here I'm making a vector of ints called scores, and then in parentheses, how big you want it to start with. So basically, this is now a vector that's got an internal array size 30 right now. But remember, you're not limited to that. So if you add some stuff to the vector later, add some stuff, you can go past 30 and it will just resize itself and make itself size 100 if it needs to, or make itself size 200, right? So you're not limited to this, but to begin with, it might be efficient to say, I'm probably going to need around 30 things because I've got 30 students in a normal class of mine. So let's start with that amount of memory, and if I need more memory later, that'll just happen automatically. Here, we're actually initializing the items, because remember, when you just make a new piece of data, it's got random garbage in it. So what this would do is it's making a vector of ints. It's called scores. There's going to be 30 of them, and they're all initialized to 0. Okay, so maybe if I need to use them in some calculations and compute some averages, I don't have random garbage in any of the 30 slots. In the last video, we saw a partially filled array that was size 100, had 100 random pieces of garbage. So maybe this would be better and just say set them all to 0 to begin with so there's no garbage in there. You can do that. And then finally, here you're declaring a vector that's initialized to be a copy of another vector. So if I have a vector called scores, which I declared up above here, now I can make a vector of ints called finals, right? And in the parentheses to the what's called the constructor function, pass in the scores vector. Remember, that actually has 30 things. And what would happen here is now you have a new vector called finals, which is a duplicate, a copy of those same 30 things. So you could do that. Are you going to have to do this in first semester programming? Probably not, but it's good to know there's a bunch of different options for conveniently setting up a new vector efficiently. It doesn't take very much typing, and these are some options. Probably for us, we might just use this first thing. That's fine. Okay, so once you have a vector declared, how do you store information in it? So it's going to look like this. There's a function. Remember, it's object-oriented syntax, so you're about to see a whole lot of object.function type stuff. So there's a function called pushback, right? It's push_back is the name of the function. And what that does is it adds one more thing to the end of your vector. So if I have a scores vector, I want to add the number 75. I'd write scores.pushback75. Remember, object.function. And so the argument coming in is 75, and the 75 gets added to the end of the vector. Push means like, I don't know, like a suitcase, more or less. So I'm pushing one more thing down into the suitcase to be stored there, and that's why they use that terminology. Now you notice that the way the function is spelled, push_back is kind of very old school. I don't think many of us would name a function that anymore. I'd prefer to use camel case. I don't like to use underscores in my variable or function names. I don't think most people do that anymore. But once upon a time they did that, and we're stuck with this syntax to that function. Okay, so that's how you're adding new stuff there. Remember, you can just add as much stuff as you want, frankly. Now, since the vector is going to be growing, right? You add more stuff, it's going to be changing size over time. There has to be some way to get that information back. It's internally storing how big it currently is. And there's a function called size to do that. So if you want to see how many things are stored in your vector, you can write scores.size, and that reports how many things it's currently got. And you could print it out, you could count it, you could use it in a calculation for an average. You could store it in another variable if you want, is what's happening here. But that's how you get at the size number that's automatically stored in your vector. It's going to be changing from time to time. That's nice. Now, on the other hand, you ought to be able to remove vector elements. And here, the function name is called popback. So it's like I have a very, very full suitcase, and I open it up, and one of the things pops out. And that's how you remove stuff. So if I call scores.popback, that just removes the one thing at the end. If the last thing that I put in was the 75, then scores.popback is to look at the end of the array and just take that out, is what's happening here. So that's how you can remove stuff. Maybe you just want to clear all the stuff out, right? You've done some kind of process and you just want to throw away all that information and restart over. There's a function called clear. Again, object.function, right? Name of my object is scores dot name of the function that's inside it clear, and that just wipes out all the data and resets the size back to 0. So that's an option, right? There's a function called empty. So sometimes we want to see, did we just clear out all of the elements in the vector? So there's a function called empty to do that. So I might be doing, input validation perhaps, or say, as long as, so this line of code here is saying, as long as scores is not empty, as long as it's not the case while scores is empty, do some processing on the data that you've got in the vector. Maybe pop one of, maybe print it and pop one out, right? If you've still got more information, print it and pop it out. So the empty function returns true if there's nothing in the vector, and it returns false if there's anything at all in the vector. So presumably this while loop here would keep processing while you have more data. And once the vector is empty, right, empty comes back as true, not true is false, and that gets you out of the loop. So you might possibly construct a loop like that. Anyway, there's the empty function to check in on whether the vector is currently empty or not. Some other useful member functions here. There is the at function. Again, for all this stuff, you'd be writing scores dot this function, or whatever the name of your vector is, object.function. So other functions that are contained and available in vector objects, there's the at function. You get to see the element at a particular subscript. So you could ask for scores dot at number 1, or scores dot at number 20. And that's basically like square brackets, right? In fact, you could use square brackets. You don't have to use this function. You could just write scores square brackets and access one of the items. Or, it's more object-oriented type thinking to use a particular function called at to do the same thing. And I would say it's actually a little bit safer because the at function does automatic safety checking to make sure you don't have a buffer overflow, whereas the square brackets don't. They don't do that automatically. So I might possibly lean, I could use square brackets, but I might possibly use the at function instead. There's a function called capacity, which returns currently the total amount of storage that you could put in the vector. Now, that can change. So if I put more stuff and put more stuff, that capacity number might actually get bigger, but you do actually have an internal array, frankly. So behind the scenes, the little secret is the vector's got an internal array that's partially filled. Okay, so there's a difference between how big the array currently is versus how much stuff you've currently stored there. So size, that we saw in the prior slide, reports how much stuff you've currently got stored in there, and capacity is actually reporting on the size of the internal array. So normally, capacity's got to be bigger than the size. It could be equal, and then it can grow later on, which is fine. So remember, vectors, they can grow as big as you want. You can put a ridiculous amount of memory in them, and they basically are just resizing that internal array automatically. That could be, depending on how much memory you have, that could be millions of things. It could be billions of things, and just, grows and keeps track of it automatically. Some slightly more exotic stuff, there's a function called reverse that just reverses everything in the vector. You might need to do that. Resize is a function to take control of the capacity level, right? So you could make it bigger or smaller, depending on whether you currently need more or less memory. There's a function called swap. So presumably you've got two vectors, and you're actually just going to swap the contents of both vectors entirely. So in this example here, you'd have to have two vectors, one called vec1 and one called vec2, and you'd call vec1, that's the object, dot swap, that's the function, pass in the other vector, and that actually automatically just swaps the contents of both vectors. So that's pretty powerful. That it probably unlikely you're going to need to do that, but the at's important and the capacity is important. So again, on your list of notes here for all this brand new stuff, you might just want to list these member functions. There's more, right? There's actually a larger story of a whole lot of other features that vectors have, but we're just kind of getting started with it. This is the basic stuff, some examples of things you can do and what it's going to look like in object-oriented syntax when you interact with vectors. All right, so here is an example program in the book that shows vectors being used. So this is program 727 at the end of chapter 7. And this program is going to store in two arrays the hours worked by, some number of employees, I would say, and also their hourly pay rates, and as usual, compute what their gross pay should be at the end of a week. So on line 5, as usual, you've got to include the vector library. We knew that. And now here on lines 10 and 11, you're declaring vectors, right? We're not declaring arrays. They're doing the same work for us, but maybe a little more efficiently. So on line 10, we're declaring a vector of ints called hours to store all the different hours worked for all the employees in your company. And on line 11, we're declaring a vector of doubles, right, called pay rate to store the pay rates of all the different employees in your company. And don't forget, vectors can store any type of data, just like arrays. Here we are making a vector of ints. You can make a vector of doubles. You can make a vector of chars. You can make a vector of strings. You can make a vector of bools. You could make a vector of unsigned chars, right? You can make a vector of unsigned short integers, right? Any type of data you can store in a vector. And then we've got a variable here for the number of employees, which is a variable, and a loop counter, because we'll have some loops as we process this stuff, of course. So on line 16, 17, you ask the user, how many employees do you have? Right, that gets stored in num employees. And notice again on lines 10 and 11, when we made these vectors, we didn't give it any size. These vectors are starting off totally empty. There's no data in them. Maybe the capacity is 0. There's not even any storage yet. So you don't have to have a constant here like you do with arrays. Like normally with arrays, we have to have an int, number of employees equals 5, and you're stuck with that. Here, you're not stuck with that. The user could say any number of employees they want. They could say 5, they could say 15, they could say 150, right? And this program is going to work for any of those. So once you have that number of employees in this variable, here comes an input loop on this slide, right? We're going to input the payroll data. And of course, prompt enter the number of hours worked by your however many employees and their hourly rates. And now you've got a loop counting from 0 to the number of employees you just said. 5 or 15 or 150, whatever. And so in this loop, you're going to see some sin statements. right? SYN statements are going to take data from the user, store it in a variable. So we have to have a couple of variables just to get information from the keyboard buffer from SYN. Okay, this is just kind of old stuff. So prompt for the number of hours, and the user SYNs into temp hours. The interesting thing is on line 30, right? Once you've got that in temp hours, here you're storing that in the hours array. So you see hours, that's the name of the object, dot push back, like we said, and you're passing in that temp hours, that one number that you just read from SYN. Okay, and so then you prompt for the hourly pay rate for employee number whatever, right? SYN into temp rate, and then on line 34, you're saving that number into the pay rate vector. So you see pay rate dot pushback temp rate. And again, object.function. And this particular vector is going to save that new number at the end of the vector. And then you loop over again, right? And you type in another number of hours and another rate, and that gets pushed into the hours array, the hours vector and the pay rate vector. And, you know, it doesn't matter how many employees there are, even if there's 150 or 1,000, right? If you push more data, you push more data, you push more data, and when it needs to, the vector will automatically resize itself to be bigger. And you put more data, and at some point say, I guess I need to be size 100 now. And then it'll be, I guess I need to be size 500. I need to be size 1,000. And this input loop is going to work. There's no constant for an array. And if you add more data, the vectors will just get bigger and bigger and bigger as much as you need. You know, hypothetically, you're limited by the amount of memory on your system. But, you know, for me, if I have, I don't know, 8 gigabytes of free memory, I would have to type in, you know, 1 billion numbers before I ran out of memory. And the vector could just grow and use up all my memory if it needed to. So almost surely you testing this, you're not going to run out of memory. Really handy. Now, that's just the input loop, of course. So now we should go see a processing output loop on the next slide. And of course, we're going to display each employee's gross pay. So here's the gross pay for each employee, right? You're going to print out money, so set precision to 2. So here's another for loop, counting from 0 to num employees, however many there are. And on line 42, see what's happening here? We're accessing the information that we stored using square brackets, just like an array. That line there looks totally like you have an array, which, you know, vectors really, frankly, are, you know, costumed up with additional features. So you're looking at hours bracket index, and you're multiplying by pay rate bracket index for whatever employee you're talking about. Multiply those two things together, and of course, that's the gross pay, and you print it out. Okay, but really the interesting thing here is line 42, right? Accessing information that you've stored in a vector, and it just looks exactly like an array. The other alternative on that line is we could have used the at function. So I suppose we could have written hours.at parentheses index times payrate.at parentheses index, and that would accomplish the same thing. And even be a little bit safer because that has the security features built in. Maybe I would have done it that way myself, but this works. This is perfectly fine. Okay, so vectors. So the really nice thing is we did not have to declare a constant. We did not have to declare the size at the start. We're not limited by some predetermined size. There's no risk of buffer overflows. This program just works for any number of employees that the user might have. So let's test this example of a program that uses vectors, and I've brought up program 727 out of the lecture code into the IDE. And of course, the whole point of this program is here's a program that can handle any number of employees, however many the user has. Now I feel, if I look closely at this header comment, it says this program stores into arrays the hours worked by 5 employees and their hourly pay rate. So I feel that that's a little bit of an error there. I feel like that might have been copied from some other program that actually did use arrays. And in that case, you were stuck with 5. I think there's another example that does that. So I think whoever wrote this copy pasted the comment, because of course, this program doesn't use arrays, it uses vectors. And you're not just limited to 5 employees. You could have as many as you want. So probably that comment should have been fixed there. Anyway, let's try it. Certainly compiles. Run this. So asking the user, how many employees do you have? Maybe I only have 3. I just have 3. Okay, so I'm entering the hours worked by the employees and their hourly rates. And for employee number 1, I think I remember when we tested that other program with arrays actually. Maybe employee number 1 worked 40 hours at $20 an hour. and somebody else worked 30 hours at maybe $12 an hour, and somebody worked 35 hours at, again, I'll say like maybe $20 an hour. Great. Okay, so stored, right, all of the hours worked in one vector, which apparently had to be size 3 by the end of it, and stored all the pay rates in the other vector, which got up to size 3, and then multiplied them all together, and here is the gross pay, and again, 40 times 20 is 800, 30 times 12 is 360, and 35 times 26. So this looks like this is working properly, right? But let me try it again. That was a really small company that only had 3 employees. So if I run this again, you know, I could have 5. Resize this so that looks nice, great. So I've got, here's my first employee, here's my second employee here, here's my third employee, here's my fourth employee. They worked, I don't know, they worked 50 hours. They should probably get overtime. $25 each. Here's someone that just worked 15 hours, but they're making $30 an hour. Great. So here's the gross pay for all 5. And again, you know, we probably ought to test this with a larger number of employees, but this program will work if you have 10 or 100 or 1,000. That's fine. As you push more data into each of the vectors, it's going to resize the array inside it to store as much as you need. It's just going to take up more and more memory of your main memory system, obviously, but that totally works for any number of employees. So that's really, really handy, and that's why probably you know, everyday working programmers like using a vector, and that dodges the whole issue of partially filled arrays. When we were working with some file handling, and you know, you're reading from a file, you don't know how many things are in it, you're using a while loop, and you want to store it previously, we had to use a partially filled array and just have a really big array, and you're probably going to just waste most of the space. So using a vector would probably be a much better idea. Of you have your while loop, and you just push more data, push more data, push more data, and it resizes itself to about the capacity that you need. And it's a lot more efficient as far as the memory, and a lot safer if you have a really, really big file. Now, you know, obviously on the other hand, testing this program here for really large companies, that's getting to be a drag. And frankly, I don't want to sit here and literally type in 1,000 employees just to test it. So you could improve this program in the other direction by adding file handling to this, and it would just automatically read in 1,000 employees instantaneously, and you could use that to test all of your gross pays. I don't think there's an example of that in the book, but that's the first thing that occurs to me, is to use file handling from the prior video to start testing programs that expect to handle larger amounts of data. And these two ideas work very, very well together. So I'm kind of glad that we talked about them, you know, at the same time near the end of our first semester of Starter C++ programming. All right, so at this point, I would ask my students to read that last section in Chapter 7 on vectors. You have some more examples, some more details than we had time for. That would be good. And then we would do a lab together. We'd come in together and we'd do this lab. Now, this is a lab that I made up. It's not in the book. There's no starter code. But we should do some kind of practice just to practice with standard template vectors for the first time. So I would come into my lab and I'd say, okay, look at that table that had the summary of vector member functions. And you can look back in these lectures right here. And you know, there's pushback, there's popback, there's the size reporting function, there's the capacity reporting function, right, which is going to be different from size. And so the goal here, and you know, it's interesting because this is kind of an introduction to what a lot of our labs in second semester programming start looking like as we learn about new objects in C++. I say write a test driver for this class using different types of vectors. So just declare some vectors, right? Try and declare a vector of ints, right? Try and declare a vector of floats. Try and declare a vector of chars or strings, right? See if you can accomplish all those different kinds of things. Store some data in them using pushback. You know, print out what you have in a for loop, you know, just to confirm that you've actually stored it. You try the pop back function to remove stuff and see what happens. And then well, I think that the most interesting thing here is I ask my students to investigate the behavior of the size and capacity members as more elements are added. So you can do this on your own, even if you're not one of my students. Try this yourself. Just write a dummy program and make a vector, add some stuff, and print out the size and the capacity, right? Add some more stuff. Print out the size and the capacity. Add some more stuff. See if you can spot a pattern as it has to resize, as we've said, as it resizes and makes itself bigger to store your added data. See if you can spot a pattern between how the size and the capacity are related. And as you do that, you're kind of thinking like a computer scientist, and you're coming up with a hypothesis about how vectors actually handle the array that they're containing. And I think that's a really interesting kind of experiment to run to see if you can see what it's really doing when it has to resize the array that it's got a handle on. So that's a good, there's a larger story. If you read that section of the book, you'll see the larger story of vectors. And admittedly, professional C++ programmers on a daily basis, they might not actually use arrays as the first thing in their toolkit. They will probably use vectors. It's somewhat easier and it's somewhat safer and it's somewhat more flexible, so it's great. But again, they don't exist in some places. They don't exist in C or assembly, and they contain an array. So certainly, I think it's a good idea to start off and understand the basic thing first, which is arrays, and then you can use the more sophisticated thing, vectors, if they're available to you. And they should be, which is great. So in the next video, we're going to come back, and there's actually a digital appendix G, and we'll talk about command line arguments, another way of getting input to a program that, again, professional programs usually use this method. You're working on the console, the command prompt. You can just give all the information to the program. It runs full speed using that information. You don't have to pause. You don't have to wait for a sin statement for the slow human user. And this also explains what the parameters coming into the main function are in both C and C++ and Java. So hopefully you'll join me for that. That's actually about the last thing for my first semester programming course. So we should add that. And then you have a very nice picture. You have a very nice picture and package of things you can do in starter C++ programming. So I really hope you'll join me for that, that last thing in my programming course. I'll see you then.